and welcome to Apna Gurukul Math. We were discussing number system NCERT chapter number 1 class 9, and we have discussed the operations on real numbers. Now today we will proceed to a new topic. We concluded the last video with a question. Like in there comes to a situation where we have to keep the numerator or denominator as a rational number, not as irrational number. So what is that process called and how do we do that? That is the objective of this particular video. Now, first of all, are we clear with operations on real numbers? I hope yes. Properties of real numbers, we discussed the closure property is not valid for irrational. That was the specific thing, and all the others were exactly the same. All the other properties are followed. Whatever we discussed, you can go back to the previous video and take a look at that. Now comes how do we make the numerator or denominator a rational number? That process is called as rationalization. We are converting an irrational denominator to a rational. So that is what is called as rationalization, and that same follows with the numerator as well. Now, there's a very good quotation. We'll start with that. Pure mathematics is in its way the poetry of logical ideas. Wow, so beautiful. Yes, whatever logic we are getting, whatever ideas we are getting, pure mathematics, it acts as a poetry in that. So beautiful statement by Albert Einstein. And the name itself makes it even more powerful. Let's move on to the process of rationalization. Now, we might require the denominator or numerator to be rational rather than an irrational. Now, for example, if you are asked to represent 1 by root 2 on the number line, it looks very difficult, right? Now, I will do a little bit of changes in the denominator. Let's see what happens. Now, I have got 1 by root 2. Now, what will I do is I will multiply root 2 to it. Why am I doing it? Root 2 to the denominator. Why am I doing this? Because we already know that if you multiply, and we discussed the reason also in the previous video, if you multiply root 2 times root 2, we get a rational number that is 2, right? So we have discussed in the previous video of properties of rational numbers. So that is why we are multiplying once again by root 2 to get a rational number. Can we only multiply this in denominator? Obviously not. Otherwise, we are changing the question and we cannot change the question. Yes or no? So that is why whatever operation we did in the denominator, that must be done in the denominator. Now, what it does? It has, now we reach to a process called finding equivalent fractions. And equivalent fractions, we have already learned that it is a valid process because whatever operation we are doing in numerator, that is done in denominator, and the operation cancel out. So that is why we are not changing the question, but we are getting what we want. So let's see how do we get that. So 1 times root 2 becomes root 2, and root 2 times root 2 becomes 2. Yes. So that's how we get root 2 over 2. Now you can very easily see 2 is a rational number. And if we have to plot the root 2 by 2 on the number line, it becomes very easy, right? Plot root 2, plot half of that. And obviously we will learn in the coming video how to we plot half of or bisector of any line segment. Obviously root 2, when we mark it, it becomes a line segment from 0 to root 2 point. We have discussed already how to plot root 2 on the number line in this particular playlist. You can go to the second or third video, you will be able to find it. I hope now that makes sense very clearly. Yes, so that is how we rationalize the denomination. That's not it in this. We will learn about that in further videos. Now, you might be surprised that we have learned that any irrational number cannot be represented in p by q form where q is not equal to 0. But over here, as you can see, root 2 by 2 is an irrational number and it is also in p by q form. And q is also not equal to 0. Yes or no? But my dear friends, we have to, that is why whenever it's a definition, each and every word in the definition is very important. Now the definition says p by q, and where q is not equal to 0, and p P and Q are integers. Yes. Now, as you can see in this particular question, root 2 itself is an irrational number. That is why please do not get confused with this particular question, because that question literally hit my mind, and then when I thought, yeah, that is what is the definition. We must be very careful about the definition. So now let's move on to the rationalization. To understand rationalization, we need to first be clear with identities for square roots. Right? We already know the identities a plus b whole square, a minus b whole square, a plus b, a minus b, and x plus a times x plus b. Now let's use these identities, understand these identities with the help of square roots. So instead of a, I have taken square root of a. So square root of a plus square root of b, the whole square. So how will the process begin? The process begins square root of a plus square root of b square will be square root of a whole square, because that is what is the formula. Then square root of b whole square plus 2 times square root of a square root of b. Yes or no? Now square root of a square is a, square root of b square is b, and under root a times under root b, we can write it as 2 times root ab. Yes? So this becomes this particular thing, and that is how we get the identities for square root. Similarly, when we go for under root a minus under root b the whole square, we get this particular answer. Now, something interesting happens over here. When we have square root of a plus square root of b, and we use the identity of its negative version, so square root of a minus square root of b, or it is also called as conjugate, because only one of the operations have been changed and the numbers remain the same. What do we get? We get a minus b. A is a rational number. B is also a rational number. When you subtract two rational numbers, we get a rational number. Yes or no? That means if we follow this identity, square root of a plus square root of a plus square root of b multiplied by square root of a minus square root of b, if we follow this identity, then we are very much sure that we will get a rational number as a result. There is no possibility of getting an irrational number. That makes this product property very, very interesting. So remember this property for y. Now, the fourth property, x plus root a multiplied by x plus root 3, root b, so you get x square plus root a plus root b times x plus root ab, and obviously in this case you will not get a rational number, you will obviously get an irrational number. If you want to know the reason why, you can go back to the previous video where we discussed the properties. Now, which one of these identities changes the irrational into rational? 100%. That there is no chances that you are going to get a irrational number back. So that is what is the identity. Square root of a minus square root of b multiplied by square root of a plus square root of b. That gives us a minus b. And that is why we will use this identity to rationalize the denominator or numerator. Mostly we rationalize the denominator, so I'll be mostly using rationalizing the denominator. Now, we are using this identity because it gives us 100% surety, because if we use this, we are going to get a rational number. Let's try to understand with an example. Now, in the denominator, we have 2 plus under root 3, right? This is obviously an irrational number. Now, what do we have to do? If you have a plus b, what do we do? Square root a plus square root b, we do square root a minus square root b. And that's not at all compulsory that both of them should be square. Why? Let me explain that. I forgot to explain that. For example, if we have a plus root b multiplied by a minus root b, are we sure that we are going to get a rational number once again? Let's try to understand. So this identity will lead us to a square minus b. So a square is obviously rational, and that's a positive rational, to be more precise. B is obviously a rational number, so this will also be a rational number. So it is not required that both of them should be the square root. Other one can be a rational number always. So that is how we use it. So over here, as you can see, we have 2 plus root 3. So what do we have to do? We have to multiply 2 minus root 3, because that is what the identity says. If it's a plus, we need to multiply the other number where the sign changes to minus. Now, once we have done this in numerator, it must be done in the denominator. Sorry. Once it's done in denominator, it must be done in numerator as well. Now, 1 times 2 minus root 3 will give you 2 minus root 3 divided by 2 plus root 3 multiplied by 2 minus root 3, so that becomes 2 square minus root 3 square is 6. Yes. So that gives us the rational number. How? Let's 2 minus root 3. So 2 square is 4 minus 3 will give you 1. So we are left with 2 minus root 3 over 1. And obviously 1 is a rational number. So we converted an irrational denominator into a rational denominator. This process is called as rationalization. That means it's a process where we convert an irrational number to a rational number. It can be numerator or denominator as well. Yes. So now let's try to do some more problems to make it much more clear. Okay. So you can pause the video and try out all these 5 questions at a go, and then we will discuss it. I hope you have tried all the videos, all the problems. So let's begin. So this becomes 2 by square root 5 minus square root 3. Now what do we have to do? We have to rationalize the denominator. My dear friends, we are only rationalizing the denominator. As I already told, mostly we rationalize the denominator. There are very few instances where we are required to rationalize the numerator. So over here, what do we need to multiply? Root 5 plus root 3. In the numerator also, it will be the same number. My dear friends, always remember, whatever we are multiplying in the denominator, the same number must be multiplied in the numerator as well. You cannot do that. You're multiplying with the different numbers according to your choice. That is the one thing we must remember. So that is equals to 2 times root 5 plus root 3, and in the denominator we get square root 5 square is 5 minus 3. So we get 2 square root 5 plus square root 3, obviously it's in bracket, and then 5 minus 3 is 2. Now since you can see this 2 is in multiplication to this whole term, we can simplify this also. So we only get square root 5 plus square root 3. Obviously the denominator is 1 and 1 is the rational number. Now in both examples we discussed, the denominator was coming to be a 1, but it's not compulsory that every time you will get a 1. Okay, we'll understand that in the very next example. So this example, 1 by 10 plus 2 root 3. Now what do we need to multiply in denominator? 10 minus 2 root 3, and once again the same thing in numerator as well, 10 minus 2 root 3. Yes. So now in the numerator, since we are multiplying with 1, it will remain same, 10 minus 2 root 3, and then we get 10 square minus. Now this one is very interesting. Please pay attention. This will be 2 under root 3 the whole square. Now I could have directly written, but you might get confused. That's why I will go through this process. Okay. So this becomes 10 minus 2 root 3 divided by 10 square is 100. Now this 2 under root 3 square, it can be written as 2 square, you can see on the top, 2 square multiplied by square root 3 square. Does that make sense? This is using, over here we have a times b to the whole power m. So we can write it as a to the power m times b to the power m. So that is what is the property we have been talking about. So let's begin. Let's move forward. So this becomes 2 times 2 square is 4 times root square is 3 square is 3. So that gives us 4 times 3 is 12. So this becomes 100 minus 12. So that's how we get 10 minus 2 root 3. Why am I writing it so much congested? So it becomes 10 minus 2 root 3 divided by 100 minus 12 is 988. Yes. So that is how we get to this answer. You can further simplify it. As you can see, there are 2 common factors in the numerator. You can bring it out and you can further simplify also. So that is how we simplify, rationalize the denominator. Let's get going to the third problem. Now the third problem says 1 by 7 root 6. Root 7 times root 6. So what will we do? I will do it here itself directly. So we need to multiply in the denominator by square root 7 plus square root 6. The same number must be multiplied in the numerator, square root 7 plus square root 6. And then we get square root 7 plus square root 6 in the numerator, and then we get 7 minus 6 in the denominator, because root 7 square is 7, root 6 square is 6. So that's how we get root 7 plus root 6 divided by 1. Yeah. So 1 is a rational number, and that's how we have rationalized the denominator. Moving to the next question, and this one is super awesome, super interesting for you guys. I'm very, very happy to explain this question, especially for them. Just pay attention very, very carefully. Now, this question, you can see the numerator is also irrational and the denominator is also irrational. But when we are doing such problems, we are only asked to rationalize either the numerator or denominator. Okay. Because as we saw one of the examples where we had to plot 1 by root 2 on the number line, over there if the numerator is an irrational, we do not bother much, but the denominator must be rational. And I have been telling that we mostly use rationalizing the denominator, because denominator is nothing but the divisor. So if the divisor is a rational number, the things come in control of us, right? That is why mostly rationalizing the denominator is an important aspect which we discuss every time. Great. So now once again, the process remains the same. So we need to multiply square root 3 plus square root 5, and the same thing we must multiply on in the numerator, square root 3 plus square root 5. Now as you can see, we are multiplying square root 3 plus 5. This becomes square root 3 plus 5 whole square, right? So the numerator here becomes square root 3 plus square root 5 the whole square, and the denominator obviously becomes 3 minus 5. So here we are getting it as minus 2. Is minus 2 a rational number? I know you're laughing. Yes, it's obviously a rational number. So we are not worried if it's a negative or a positive. We can obviously take this negative to the numerator. But first of all, let's solve this numerator. Obviously, we know the identity of root a plus root b. So this gives us 3 plus 5 plus 2 under root 3 times 5 is 50. Yes. And that is how we get to the answer. Fifth question is much more interesting. Now, fifth question, as you can see, denominator can be simplified there itself, right? Root 5 plus root 5 can be 2 root 5. Now, if we do not take a look at that and if we blindly start doing this process, let's try to understand. Now, I took this example with a specification. When you start, when you right, you cannot solve it further, right? I hope you understood the meaning of that. So this becomes, I will follow the exact process. So root 5 minus root 5, and the numerator becomes root 5 minus root 5. So you get root 5 minus root 5 is 0 divided by denominator is root 5 minus root 5 is 0. So we get 5 minus 5, which is also 0. 0 by 0. This is an indiscriminate form. We cannot get this when the question, when the process is. We do this with simple process. Okay, it's very, very simple. You just reduce it. So this becomes 1 by root 5 plus root 5 is 2 root 5. We have already discussed. Now root, we can just multiply it by root 5 times root 5, because root 5 times root 5 will give you 5. So then it becomes root 5 divided by 2 times 5. That gets us to divided by. Yeah. That is how we get to the answer. I hope rationalizing the denominator concept is very, very much clear for you all. If you have any doubt, you can just comment down. I will be happy to react to the comment. I will be happy to discuss with you. Right? So As I promised, we'll have live sessions every Sunday at 12 p.m. We'll be starting that very soon, and then we'll have live question answer session. I hope you love this video. Thank you so much for being with Apna Gurukul man. See you in the next video. Till then, keep smiling. Jai Hind.